This time on our global roundup of the greatest engineering catastrophes, America's first space station threatens to fall to Earth.
We had 3 mission control teams, each on for 8 hours, and we began to control the Skylab 24 hours a day.
Modern waterworks destabilize an ancient Italian town.
I'd hate to be the one cleaning up that mess.
A skyscraper that was almost sweeping people off their feet.
The height, the position, and the concave shape of the building were the perfect conditions to create the perfect storm on the streets below.
And brand new trains get too close for comfort.
This led to one very close shave.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings. These are the massive engineering mistakes that only an expert can hope to fix. Engineers are constantly pushing the boundaries, striving to haul the world into the future. But when those creations are right on the limits, engineering errors can be revealed in dramatic style. For this first engineering catastrophe, we're heading into orbit and a space station that threatened to crash down to Earth.
This engineering disaster is out of this world.
A sequence of engineering fails struck the station, and people across the planet looked up in fear.
Big space station, don't know where it's coming down. I need a helmet.
July 16th, 1969, and Apollo 11 carried the first humans to the moon.
It's one small step for man, one giant leap for mankind.
Apollo 11 and the 5 moon landings that followed still rank among the greatest achievements in history. And yet, these were the first small steps in a massive engineering challenge, our quest to explore new frontiers in space. As author David Hitt explains, our ambitions went beyond moon rockets.
From the beginning of planning for space exploration, there was an understanding that at some point, if we're wanting to live in space for long periods of time, if we're wanting to go places out in deep space, we're going to need a platform to enable that.
NASA's experimental solution was a space station called Skylab. The plan was to launch it on a Saturn V moon rocket. The rocket would fall into the ocean, leaving Skylab in orbit around the Earth.
Skylab was built to be a workshop and solar observatory in space that would orbit the Earth almost 5,500 times a year.
The space station, complete with laboratory, kitchen, bedrooms, and bathrooms, would be launched unmanned, with the crew sent up 24 hours later. After 6 successful moon landings, NASA engineers had total confidence in the Saturn V rockets, but one crucial piece was untested: Skylab itself.
10, 9,
On May 14th, 1973, the new station was launched.
5, 4, 3,
61 seconds into flight, at 1,100 kilometers an hour, Skylab punched through the sound barrier. As shockwaves shook the rocket, alarms sounded in mission control. Instruments on Skylab recorded a short, unexpected sideways force. As engineers raced to decode the data, the rocket hurtled on, and 9 minutes later, Skylab was in orbit. Data streaming to mission control indicated that a paper-thin protective shield, the size of a billboard, had been ripped from Skylab's side. As the astronauts headed home to rest, they didn't know if they'd fly the next day.
Before they even get home, they're hearing, hey, we've got a problem here. We have a space station in orbit, but it's crippled. And the question then becomes, just how bad is it?
If the data was right, there were two major problems. The lost panel doubled as a heat shield, and the damage was blocking a solar panel from opening, leaving the station dangerously low on power and at risk of overheating. The crew was scheduled to head to Skylab the following day, but the risks were deemed too great. The launch was postponed. It took engineers 10 days to address the problems.
You have people throughout the agency working to figure out what's happened here and what can we do to save it. And 10 days was an insanely short amount of time.
3 years earlier,
Okay, Houston, we've had a problem here.
NASA engineers and crew had brought the stricken Apollo 13 safely back to Earth. This time, although no astronauts were on board, the team still didn't want to lose their space station. As the crew trained for the unexpected repair mission, two seamstresses stitched together a sunshade. Meanwhile, engineers worked round the clock to come up with an emergency repair procedure. 11 days after the initial disaster, the three-man crew launched on a mission to save Skylab. They had no idea what condition the space station would be in, and before docking, they flew a visual inspection. This revealed engineers had been right.
During launch, one of the thermal panels broke away, ripping off one of the spacecraft's two solar panels. This prevented the other one from opening and exposed Skylab to excessive heat.
NASA's official report concluded that a combination of engineering fails were to blame, from miscommunications to flawed components. The result? As Skylab went supersonic, shockwaves forced air behind the shield, and it was ripped from the rocket, damaging the solar panel as it went. With their visual inspection over, the astronauts prepared to dock with Skylab and try to repair the damage.
Although the astronauts were never meant to leave their spacecraft, they actually had to climb on the outside of Skylab to address the fault.
To make Skylab safe, astronauts had to both install the sunshade to cool it down and deploy the damaged solar array to increase power. Luck was on their side.
They very fortunately get out there and discover that there's actually a islet in a place that wasn't on the trainers. So thankfully they're able to run a tether through that to get purchase in order to use their clipper to cut the piece of metal that was holding the solar array in place. It deploys outward, and now for the first time they have something resembling the amount of electrical power that they were supposed to have.
2 weeks after launch, the power and temperature problems were resolved. Skylab had survived its first engineering catastrophe. The multi-billion-dollar program was back on track.
With the problem solved, the lab was now working, and in its first year of orbit, 3 different crews lived on board.
They're able to start doing the biomedical research, the Earth observations, the solar observations, the science that changed the way that we understand our planet.
3 crews and thousands of experiments later, the Skylab mission was declared a success. The station was left in gravity's grip and expected to fall to Earth in 10 years. But the engineering fail that made Skylab world news was yet to unfold. It was coming down much sooner than planned. The 77-ton station was expected to splash harmlessly down into the Indian Ocean in March 1983. Gravity pulls all satellites down to Earth. But in the mid-1970s, NASA engineers discovered the massive lump of metal was losing orbit faster than expected. With Skylab, it seems they had underestimated the power of the sun.
Once the last astronaut had closed the door behind him, the space station was supposed to orbit the Earth for another 10 years.
Skylab is there and it's in orbit, and it's essentially at that point been abandoned. It's flying overhead, people remember that it's there, but it's not being used, it's not active. What is active during this time is the sun, and in a way that nobody had anticipated.
We think of space as a vacuum, but Skylab's orbit was influenced by the Earth's atmosphere. In the mid-1970s, the sun was unusually hot. The result? The atmosphere heated up and expanded. This created drag on the space station, slowing it down and starting to pull it out of orbit.
NASA had underestimated the impact of solar activity, which had effectively halved its lifespan.
The result? Skylab would crash back to Earth 4 years earlier than expected.
Skylab was a very large chunk of metal, and people kind of understood that this was a thing that it had taken a giant rocket to put in space. This is a big thing that's up there, and now it's going to be coming down.
To buy them time, NASA looked at ways to keep Skylab in orbit. One audacious plan depended on a revolutionary spacecraft that was still in development, the Space Shuttle. The shuttle would carry an Apollo capsule up to Skylab and use the capsule's thrusters to boost Skylab into a higher, longer-lasting orbit.
So now we have a space station up there. The atmosphere is expanding faster than we anticipated. It's putting more drag on Skylab than we anticipated. And at the same time, down here on Earth, work on the space shuttle is taking longer than was originally anticipated.
Skylab's re-entry was getting closer, but the space shuttle's launch was delayed.
Eventually, it's realized these things aren't going to cross. The Skylab is going to come down before the space shuttle starts flying.
Skylab was going to crash back to Earth years earlier than expected, and where it would land was anyone's guess.
The idea of dropping it on somewhere like Idaho or Mississippi really got people thinking, however remote the possibility.
You had people who were selling and buying Skylab hard hats to protect them. You had kind of a general sense of panic that is this thing going to land on me?
NASA engineers weren't just going to stand by. Professor Bonnie Dunbar is a former shuttle astronaut, but at the time was a navigation officer at Skylab Mission Control.
When NASA realized that the shuttle wasn't going to make it on time and that the Skylab was deorbiting faster than anticipated, said, well, we're going to be responsible about finding a way to deorbit it in a particular place.
The real aim was to ensure that the final entry was over the sea or an unpopulated area to avoid disaster.
The Southern Hemisphere has fewer people and more water, so Bonnie and the team planned for an Indian Ocean splashdown. However, the ailing space station wasn't designed for major course corrections. All they could do was adjust its angle relative to the atmosphere.
You have the ability to change the orientation of Skylab, but it's very limited, and that's all you have to work with. At this point, they're controlling the space station, they're controlling its re-entry simply by turning it and increasing the drag.
It's sort of like putting your hand outside the car window and letting the wind hit it. If it's flat-handed, it's going to drive your hand back, and there's a lot of drag there. It'll actually slow you down if it were big enough. But if you put it sideways, it's like a wing, and so there's not much drag.
Changing Skylab's angle would influence its speed and how quickly it would lose altitude. In theory, this gave NASA some control over where and when the station would come down, but would they be able to bring it down safely? Yes, America's first space station was falling to Earth 5 years earlier than anticipated. But NASA engineers were working 24/7 to control where it fell.
We had 3 mission control teams. We were each on for 8 hours, and we began to control the Skylab 24 hours a day for 9 months.
Finally, on July 11, 1979, Skylab started its final descent through the Earth's atmosphere. 16 kilometers up, hurtling faster than a speeding bullet, the space station started to disintegrate. Several large pieces survived re-entry and smashed into parts of Western Australia, but luckily, no one was hurt. However, Australian authorities did fine NASA $400 for littering.
It taught us from an engineering point of view as much from its re-entry as it was when it was up in orbit.
The Skylab mission was plagued by engineering problems, but NASA learned vital lessons which have taken space exploration to whole new frontiers.
Really, everything that we're doing in spaceflight today is because of what we did with Skylab.
Despite its problems, Skylab was still a hugely successful mission. Not only did it teach us a lot about what's out there, it taught us a great deal about engineering too.
Construction calamities can threaten even the most robust structures.
If all the computations are correct, these connections would have broken.
But as every engineer knows, if you build on soft foundations, you're just asking for trouble. Like this story in Italy, a catastrophe that created a ghost town.
We've all seen ancient ruins, but Krakow is an ancient city abandoned in modern times.
Perché aver abbandonato questo paese, il quale ci ha dato tanto, sento tristezza.
An engineering project to modernize this historic Italian town's waterworks helped trigger its downfall.
Krakow survived earthquakes, volcanic eruptions, even war. In the end, they were done in by some plumbing.
Krakow, in southern Italy, with its imposing hilltop defenses, held attackers at bay for more than 1,400 years. And despite appearances, it was full of life until the 1980s. One of Krakow's last residents, Sfera Domenico, recalls a good life in the town.
Ci si viveva bene, c'era vita, c'era tutto, avevamo tutto. Era un piccolo paese, ma avevamo tutto.
Sfera's hometown thrived for so long, not just through its defenses, but the surrounding landscape too, as architect Francesco Manfredi explains.
Non era solamente un caso che si andasse a costruire sulle cime, sulle montagne, sulle alture, magari dettato solo da aspetti legati alla difesa, in un'epoca in cui la difesa era quasi un elemento fondamentale per la costruzione dei centri abitati, ma anche la conoscenza geologica.
For centuries, Krakow sat safely on solid rock at the top of its mountain. 2 rivers at its base created fertile and rich farmland. According to archaeologist Nicola Massini, these were golden times indeed for the town.
Historically, was known as Monte d'Oro, which means in English gold mountain. The period of greatest prosperity is the 16th century, when the village counted about 2,500 inhabitants. In this period, the village expanded from the tower towards the valley.
But as the city expanded, that created a problem for town planners. The town's founders built Krakow directly on the exposed rock at the top of the mountain. As the population grew, room on the rocky surface reached capacity, and buildings had nowhere else to go other than down the sides.
In fact, Krakow's growth and prosperity was ultimately part of the problem.
The trouble is, although the mountain on which Krakow stands looks solid, this whole region is geologically unstable.
Basilicata is the region of landslides. It was something that occurred all over the South Mediterranean region, but in Basilicata there was also the component of the geological fragility.
This geological fragility is caused by a combination of soft ground and sloping sides. The sides of the mountain are formed by a layer of clay 50 meters deep, sitting on solid bedrock. Clay is made up of small, densely packed particles. When it gets wet, it turns soft. And with the added water, it gets heavier.
The danger of building on clay is that if the clay gets too wet, it can slide along the bedrock underneath, taking whatever is on top of it for a ride.
The steep slopes in clay explain Krakow's long history of landslides. For hundreds of years, the slides were small and local, just part of life in Krakow. But in the mid-20th century, it seems engineers modernizing the town triggered events that helped to destroy it. Traditionally, residents drew their water from wells beneath the town. But in the mid-20th century, engineers installed modern water and sewage pipes. As geologist Giuseppe Locoratolo explains, this had a massive impact on the area.
I pozzi sono stati abbandonati, non è stata più tirata acqua dalla falda, perché l'acqua arrivava tramite le condotte idriche.
With no more groundwater being taken from the wells, the water table was saturated. So the clay was more prone to moving around, which cracked the plumbing and caused trouble for the town above.
In più, il movimento franoso ha fatto rompere le tubature dell'acqua e quindi da queste tubature è iniziata a fuoriuscire dell'acqua che ha peggiorato, ha accelerato il processo di la dinamica, il movimento sostanzialmente della frana.
Krakow survived hundreds of years of earthquakes, volcanic eruptions, the bubonic plague, even war. In the end, they were done in by some plumbing.
In 1959, heavy rains added to the already saturated clay, which over the next year or so triggered a series of slow but disastrous landslides. As local historian Savio Grippo reveals, the damage was catastrophic.
Behind me you can see the old town of Krakow. You can't see anything more, but you should imagine that all around us before we had houses. This was in fact the center of Krakow. They built in areas who were not exactly stable like the rock and activated this process of landsliding, who little by little brought down all the new area of the city.
The expanding city was built on clay instead of the solid rock in the city center, thus the instability.
Just the part on the rock remained standing in the exactly same position.
In an effort to stabilize the ground and stop the slides, engineers dug massive retaining walls 30 meters down into the clay of the hillside. But as geomorphologist Domenico Capolongo explains, it just made things a whole lot worse.
We see here the last made retaining wall done in the 1970. They went down 30 meters roughly, but the clay bedrock is 50 meters down.
The concrete pillars fell 20 meters short of solid bedrock. Instead of protecting the hillside, the wall added weight to the already unstable clay, making the problem worse.
They added a lot of weight more on the side of the hill, so accelerating the process of the landslide. After it, they could not solve the situation anymore, and little by little, all the center of Krakow slided down, damaging and destroying all the houses present here.
I danni si vedevano giorno per giorno, non è che si è visto tutto una volta, addirittura si vedevano perché le lesioni che apparivano nelle case si aprivano e si vedeva addirittura il sole all'esterno, la luce del sole.
The ongoing landslides, and then finally an earthquake in 1980, left the town uninhabitable, and residents left for good.
Siamo stati costretti ad andare via, ad abbandonare e andare via, dove abbiamo abbandonato anche le masserizie, molti hanno abbandonato anche le masserizie, perché non si sapeva dove portarle.
Krakow was once a thriving town with a university, a castle, a church. Now it's a ghost town.
Venire qua è una tristezza comunque, è una tristezza. E vedere tutto questo scempio è una tristezza, perché ci sono tanti ricordi.
To prevent this once thriving hilltop town from disappearing from history, the World Monument Fund has placed Krakow on the watch list to help pay for conservation efforts.
Quindi qui a Krakow non sappiamo che cosa si poteva fare, ma sappiamo cosa non si sarebbe dovuto fare.
Now, Krakow's only guests are sheep, donkeys, and the occasional Hollywood movie star.
This particular place was also used for several movies, like The Passion by Mel Gibson, James Bond Quantum of Solace, or even an entire horror movie.
We've all seen ancient ruins, but Krakow is an ancient city abandoned in modern times.
Construction mix-ups can strike anywhere. From cities to the backwoods, from bridges to dams. But nothing grabs the public's attention more than when engineering goes wrong on a skyscraper. Like these stories. First up, an iconic piece of the Manhattan skyline. 601 Lexington was built in 1977, and its revolutionary design is as impressive today as it was then. The 59-story Goliath was built on stilts, but unconventionally, they are not at the corners. Engineers were confident that the structure was sound. However, a miscalculation uncovered by a student revealed that strong winds could topple the building.
The entire building would have fallen sideways.
There could be up to 200,000 fatalities.
The problem lay in the internal steel structure.
The contractor modified welded connections to bolted connections.
A weld would take much greater forces than a bolt.
All 200 bolted joints had to be welded over to improve the building's strength. Fortunately, the fix was completed in time and tragedy was averted. From a hidden design flaw to a sinking subterranean nightmare. San Francisco, California. Completed in 2008, the Millennium Tower is 58 stories of prime real estate. But soon after these multi-million-dollar apartments opened, residents noticed something wasn't quite right.
One of San Francisco's tallest residential buildings was sinking.
Engineers had built a foundation consisting of a huge concrete slab, supported by friction piles sunk deep into the ground. However, during construction, it seems some steel elements were switched to concrete, making the tower a lot heavier. Although the developers don't agree, some believe the existing foundations were too weak. Either way, the building is not only sinking, but leaning too.
He rolled this marble 10 feet toward me. The marble slowed to a stop, turned around, and rolled back.
One potential fix involves the installation of more piles, this time all the way down to the bedrock. But the cost is estimated at over $100 million. For now, the residents of this West Coast icon will have to keep their balance. Next, to London, England, and a tower that was struck with a very surprising problem. The Leadenhall building, nicknamed the Cheese Grater because of its unique shape, stands at 52 stories. Opened in 2014, this skyscraper's distinctive design set it apart from its neighbors. Rather than opt for a central concrete core to support the structure, engineers surrounded it with an external megaframe, all held together with 3,000 massive bolts. Only months after opening, disaster struck when 2 of the giant megabolts fell from the building.
Can you imagine a bolt the size of my arm falling from the 19th floor of a skyscraper?
Soon after, a 3rd bolt fell. Fortunately, no one was injured. The bolts had suffered a chemical process that caused them to crack. Engineers knew that the only sure fix was to replace every single bolt. The repair cost millions, but at least it's now safe to walk beneath. Staying in London, Our final skyscraper isn't sinking or losing a piece or two, but it was having a major impact on people below in a totally unexpected way.
Believe it or not, until fairly recently, buildings in London's financial district were relatively short, but now they're playing catch-up.
The people of London love giving their buildings nicknames. We have the Gherkin, the Cheese Grater, and the Walkie Talkie.
Standing 38 stories high, when built, 20 Fenchurch Street was one of London's tallest buildings.
The Walkie Talkie is a true mega-buck skyscraper. When it was sold, it was the most expensive UK building ever.
But since opening in 2014, this design marvel has been fraught with issues. Thomas Lane, editor of a building trade magazine, has written about the Walkie Talkie.
This building has suffered from quite a few environmental problems, famously the melting of cars.
The owner of a luxury Jaguar was shocked to find that the building had caused damage worth around £1,000 to his parked car.
The shape of the building, because it curves in at the curves at the front, actually has the effect of focusing the light like a lens.
For 2 hours every day, its unique shape was focusing the sun's rays into one concentrated spot, creating temperatures of over 90 degrees centigrade at street level.
The problem cost millions of pounds to fix. No wonder the building got the nickname the Walkie Scorchy.
Engineers solved this problem in May 2014 with slats on the front of the building. However, this wasn't the end of the Walkie Talkie's issues. The tower was wreaking havoc not just with light, but with air. Volker Butgerit is an aerodynamics expert from London's Imperial College.
If you put up a tall building in London, then this building is generally of a much larger scale than the surrounding buildings. And what that means is the potential for the building to impact on ground level wind environment is much stronger than it would be otherwise.
On windy days, pedestrians on the ground near the building were finding it tricky to stay upright. This drafty problem was again down to the building's curved shape. Justin Parkinson works close by.
But when it did open, there was another criticism about the wind that it created, the so-called downdraft. It was causing women's skirts to rise, it knocked over street signs, and people were just wondering why this particular part of London was so much windier than neighbouring areas.
This downdraft effect occurs when southwest winds hit the front of the building. They're forced down towards the ground. The downdraft is made worse by another factor of this old city. Its narrow, intricate network of streets focus the wind.
This part of London really wasn't designed for skyscrapers. Its plans were drawn up in the 1600s and it was made up of lots of tiny, narrow roads.
The height, the position, and the concave shape of the building were the perfect storm of conditions to create the perfect storm on the streets below.
The combination of strong winds and narrow streets causes a phenomenon known as the Venturi effect. Here, this occurs when air is forced through the narrow streets, resulting in a drop in pressure, but an increase in speed. The ancient roads around the Walkie Talkie have become wind tunnels.
So you can have a tall building that might be causing a downdraft, and that might have a certain strength, but if you then have an Venturi effect, that can really cause quite high winds.
A series of clever solutions were put in place to tackle the tower's wind issues.
Once it was discovered that the downdraft was causing this effect below, the building's management took steps to alleviate it. They put a canopy at the bottom of the building to stop the wind hitting directly at street level.
What that does is it doesn't prevent the downdrafts from occurring, but it prevents them from reaching ground level. So the downdraft occurs, it disperses at high level, and so at pedestrian level, the public realm doesn't really see it anymore. So what you then need to do is really have local wind mitigation schemes in areas of interest, so soft landscaping, hedges, that sort of thing. Sometimes when you walk around tall buildings, you can see those things in action.
It might sound simple, simple, but something as easy as planting trees and bushes can lessen the impact of the wind.
As well as the wind canopy and soft landscaping, to diffuse the wind, engineers also added a steel mesh to the side of the building.
Well, I think the trees and the canopy were probably fairly cheap, but this row of grates across the whole side of one building that's got more than 30 floors must have cost an absolute fortune. Just imagine being the person who had to climb up there and do that job, and the designer who had to work out how to install them.
The world will continue to look to London as a leader in architecture and design. But when engineers push the boundaries, there will always be problems that have to be solved.
I'm sure that in future architects and builders will take greater pains before the building's actually constructed to work out the effect of the wind, so they don't end up spending millions and millions of pounds on alleviating it.
Next, to France, and an engineering mix-up of epic proportions.
This led to one very close shave.
This baffling engineering blunder came at a massive cost.
A €15 billion project? This mistake is almost impossible to comprehend.
Since France's first railroad began operation 2 centuries ago, the system has grown rapidly to be the second largest in Europe, with almost 30,000 kilometers of track. It's operated by France's national rail company, SNCF, a member of the International Union of Railways, the UIC.
The International Union of Rail was formed in 1922, and it helped to standardize railways and trains throughout the world. It now has 194 member countries across 5 continents.
Millions of passengers pass through France's stations daily, but due to its popularity, the railroad now faces a problem: the need to carry more passengers. Building more lines wasn't an option due to land limitations and construction costs, and the schedule was too packed to run more trains on existing lines.
So one solution was just to make bigger, wider trains.
In 2009, SNCF ordered 2,000 new trains to be built at a cost of €15 billion. The new models would be wider, not only carrying more passengers, but allowing step-free access from platforms. Journalist Mark Frezos knows the story.
La conception de ces trains date des années 2009. Les régions voulaient des trains qui aient de grandes capacités pour transporter le plus de passagers possible sur des zones interurbaines, entre les grandes villes et la banlieue, entre les grandes villes et la campagne, et voulu un train donc très large, où on puisse mettre 5 personnes de front.
But when the new trains came into operation, a massive engineering mix-up came to light. The carriages would not fit into certain French stations. Transport writer David Haydock has an in-depth knowledge of railroads.
There are 2 very important things in order to build the trains the right size. The first one is the track gauge, which is the distance between the rails. The second thing which is important is the loading gauge.
The loading gauge defines the maximum height and width for railroad vehicles and their loads. It ensures safe passage under bridges and through tunnels. Loading gauges can vary across any network, even if the track gauge remains the same. In this case, the loading gauge of the new trains was too large for over 1,000 French stations.
The trains didn't fit. It was like a DIY nightmare on a national scale.
This oversight was down to a mix-up in the figures surrounding standardization.
The problems came when these trains started to run on the network, and they were found that they would be too close to the platform.
Local activist Eric Sowry is frustrated with the situation.
The engineers of SNCF, they finally understood that there was a problem,
when they made the first trial for real, which is incredible. When you face the reality with the first trials, oh my gosh.
The carriages of the new trains were 20 centimeters wider, making them too large for many station platforms. The platform overhangs would make it impossible for them to even enter these stations at all. When SNCF ordered the new trains, they consulted the organization responsible for maintaining the French network, the Réseau Fer de France, or RFF.
There are two massive organizations employing hundreds of thousands of people, and sometimes when you get large institutions like this, information can get lost or muddled.
The RFF said that all stations were built to the international standard. But it turned out that was only the case for platforms that were less than 30 years old.
Il y a des choses qu'il faut savoir, c'est que au fil des années, les gares évoluent, les quais sont refaits, les quais sont reconstruits ou sont élargis. Et que ça, c'est au fil de l'évolution. Et personne ne sait vraiment aujourd'hui quelle est la dimension de ce quai, est-ce qu'il est conforme à sa dimension d'origine il y a 50, 60 ans.
So here you've got these new trains fitting international standards going into these old stations that each had their own unique specifications of the time.
Realizing what had happened, SNCF had to work out how to solve the problem.
In a situation like this, there are two possibilities. One of them is that you actually move the track. Now, the problem with moving the track is that you would have to bring along an extremely expensive and very long train, which removes the ballast, which is the stones underneath the rails, pick the track up and move it slightly, just a few centimetres one way or the other, put it back down again and then put more ballast back. And that would cost a small fortune. So you actually deal with the station platform and plane a little bit off the edge, a few centimetres off the edge. It doesn't cost very much at all.
The engineering fix was to modify every station to accommodate the wider trains.
It's maddening to think that they had to get in there with angle grinders and shave down the entire length of each platform.
On average, 2 centimeters of platform had to be removed from around 1,000 stations across the country.
The official figure for the number of platforms to be modified is 1,300 out of 8,700 in France. But the number is bound to go up as more modern trains are ordered by the regions.
The fix cost French taxpayers 80 million euros.
C'est vrai que je me mets à la place de ceux qui, eux, tous les jours payent le train, payent un abonnement, payent des impôts pour ça, et derrière, c'est vrai que c'est pas clean de ne pas vérifier ces informations avant de faire quelque chose d'aussi conséquent, d'aussi important.
I thought that it was a really, really big mistake. I mean, well, it's not fit. I mean, it's millions of euros. That there was a big, big disappointment for everyone.
Although trains are still running in France, this is one engineering catastrophe they'd rather forget.
The 15 billion euro project was almost totally derailed.
Construction calamities come in all shapes and sizes, from out of this world
Okay, Houston, we've had a problem here.
back down to earth. The towering to the ridiculous.
And Mario Bagno want to build this place following Las Vegas or Disneyland.
So long as we keep building, there will always be more engineering mistakes to fix.